Right, so let's discuss about the last set of 10 questions to do with assembly and machine code. So my first problem, we are interested in defining a machine code to say, when we say machine code, what exactly are we interested in? So these are a set of zeros and ones. So it is a set of zeros and ones which are machine dependent, and they can be directly executed by the CPU. So next we are interested in advantage of assembly language. You see, assembly language, it uses mnemonics which are easier to read and write. So it uses mnemonics which are easier to read and write. Or uses human readable instructions, terms like load, in for input, out, display, and branch for change of flow of program execution. Then next, we are interested in description of pass one of a two-pass assembler. So here, what will happen is we read all instructions. So the first part is to read all assembly instructions. And the goal is to generate opcodes, but no machine code is generated at this stage. So we just identify labels and we store address, memory address of each label. So store memory address of each label. Then we might move on to generate an opcode, but no machine code is generated at this stage. So no machine code generated at this stage. Then next we are interested in two categories of assembly language instruction. So we have got data movement instructions. So move is just an instruction in assembly language. So we have data movement instructions, like load, move, you name them. We have arithmetic or logic instructions, arithmetic or logic instructions. You want to perform operations such as AND, or add, sub for subtract, all those, they fall under arithmetic or logic instructions. Then the next question is, we want to explain register addressing. So in register addressing, the operand is stored in CPU register. So operand is stored in CPU register. That's register addressing. Then what's the purpose of this? It allows for faster access. In other ways, if we want to access whatever that's stored in the memory register, is easier because it will be closer to the CPU. Then we want to dry run load register 1 with a number 6. So for the first part here in register 1, the value that will be stored is 6. Then second, we subtract register 1 with a number 2. So in register 1, we end up having 6 minus 2. So finally, register 1 will be storing a 4. I think that's the basic operation that will be happening on that register operation. So perform a logical left shift on the following number. So logical left shift, we are shifting all the bits to the left one step, and whatever that remains before we postfix or put a 0 there. So here we are having 3 zeros and a 1, so we'll end up having 2 zeros, 1, 1, 0, 0, 1. Then where there's nothing, we put a 0 there. So we've performed a logical left shift on that number. Perform a logical right shift. So we are moving to the right. So we put 3 zeros there. So it means to the right, we will now have as our results 2 zeros, 1, 0, 1. So we have 2 zeros again. So where there was nothing, because we moved, we now prefix with a 0. State one effect of shifting bits left. So this is more like doubling the value. So it's doubling the value, because as we move 1 bit, everything is doubled. So that's doubling the value. What is meant by bit masking? So this is performing a logical AND, and this logical AND is operated to test whether a bit is set or not. So this is using a AND process to check if a bit is set or not. And the result of 1 tells us that the bit is set. Result of 0 tells us the bit is not set. I think that's it for this set of questions. Thank you, folks. I hope you found this session or set of questions informative as far as assembly language and opcodes are concerned.